Some people ask me if I would work some of these out for you and go through the practice problems and try to explain them. So I'm going to try to do that. I'm probably going to go kind of quickly. If you have any questions, you can send me an email tonight and I'll do my best to answer that for you. This asks for the domain and the range of the function that's represented in this graph. If you'll look, domain is from left to right. So this domain is going from 0 to 5, and it includes both 0 and 5. There's closed dots at that. So the domain is from 0 to 5, both with a bracket, which means my answer has to be B. That's the only one that's from 0 to 5 with brackets. Let me check the range to make sure. The range is your Y values, and they also go from 0 to 5. So that is correct for number 1. It's B. Number 2. They also want the domain and the range. The domain on this one, in these particular problems, and I know I told you in class, but I'll tell you again, if they don't have dots on the end, you can assume that those are arrows on the end. So when we're talking domain, it's going from left forever to right. So from negative infinity to positive infinity. So that means I can take out A and B. Those are not my choices. And my range are my Y values. And so since it's pointing down, means that'd be from negative infinity up to 3. So the range goes from negative infinity up to 3. My answer would be C because it doesn't, the range of the Y values don't go above 3. All right, number 3. I'm going to go kind of quickly. Now, why does that say number 5, 6, 7, 11? That's not good. I'm going to pause it for just a second, see if I can find number 3. All right, I'm back. I found number 3. It's a good thing. So the domain is going from left to right, so it's from negative 3 to positive 2. Negative 3 is going to get a bracket because it has a closed-in circle. Positive 2 is going to get a parentheses because there's an open circle. So bracket at negative 3, parentheses at 2. My answer is going to have to be D. You check the range. It goes from negative 2 with a bracket to positive 3 with a parentheses. So that is the correct answer, D. Number 4. People were confused about this because of the pies. Don't let that confuse you. We're talking about left to right. Move this up so we can see it a little bit better. The domain is going from this point, which is negative pi, to this point, which is 2 pi. And so that means B is going to have to be my choice. The range is going from negative 3 to positive 3. So it's still B. That is confirmed. Number 5, determine where this is increasing, decreasing, and constant. 1, 2, 3, 4. Is that negative 4? Negative 4 here, positive 4 here. It is constant from negative 4 to positive 4. Remember that increasing, decreasing, and constant, ooh, I messed that up, only have parentheses, no brackets in any of this. If you look down here, that's all your choices are all parentheses. So it's constant from negative 4 to 4. So it's either going to be A or C. I knock out a couple of things. It is increasing from 4 to infinity. And it's decreasing from negative infinity to negative 4. So there we go, it's C. Number 6, when is this increasing, decreasing, or constant? It's not constant anywhere. So it's decreasing, and remember, we're increasing and decreasing, we're talking about X values. When are the Y values decreasing? Our answers are going to be X values. So from negative infinity to negative 1, it's decreasing. And then from negative 1 to infinity, it is increasing. So decreasing from negative infinity to negative 1, increasing from negative 1 to infinity. It looks like though that is my answer right there. I've got increasing first. So negative 1 to infinity is what I'm looking for, and that's the only one that would have that. Number 7, again, constant is from negative 5 to negative 2. And if you look at the constant, the only one that has negative 5 to negative 2 for constant is C. I can look at these others. It's increasing from negative 2 to 0 and from 3 to 5. Make sure negative 2 to 0 and 3 to 5, and it's decreasing from 1 to 3. So it does fit for the rest of the questions. But all I really had to look at was when was it constant. All right, number 8. Is this the graph of a function? To tell whether something's a graph of a function or not, you can use what's called the vertical line test. And if vertical line would only cross it once, it is a function. So yes, number 8, this is a function. Number 9 is, look where you could draw vertical lines. Yes, this is a function. Number 10, no. because I could draw a vertical line right here and it would hit it 1, 2 times. So if it would hit more than once, it is not a function. Number 11, even, odd, or neither. Okay, even is if the y-axis splits it in half. It doesn't have to be a parabola, but the y-axis has to go right through the middle. Odd is if it's rotated about the origin. It could be something like this, or it could be something that, another odd would be something that would go up and up, something like that, where these are exactly opposite of each other. So this one to me appears to be odd because this and this, they look exactly rotated around. So odd is going to be my answer on number 11. Number 12, it looks like to me that this y-axis is cutting it in the middle, so that is even. And number 13, this appears to be neither. The y-axis is not cutting it in half, and it's not rotated, so that's a neither. Number 14. Using the graph, determine any relative maxima or minima of the functions and the interval on which the function is increasing or decreasing. So it looks like there's a minimum value of -2. Remember, minimum and maximum is your y value, so that looks like the minimum is, and this minimum because it's a low point, is -2 when x is 3. So a minimum of -2 at x is 3. This has to be my answer. Let's verify, it's increasing from 3 to infinity and decreasing from -infinity to 3. So that does fit. All right, number 15. It looks like to me that there's a relative maximum of 1 when x is 0 and a minimum of -3 when x is 2. Let's see, maximum of 1 at x is 0, minimum of -3 at x is 2. So my answer is going to have to be B. Let's double check the rest of it. Increasing from -infinity to 0, and then from 2 to infinity, and decreasing from 0 to 2. All of that matches up. 16, solve this. All right, I'm going to put this in my calculator. All right, so I'm going to go to my y equals and type this in, 6x cubed plus x squared minus 6x minus 1, and I'm asked to solve this. So when would this expression be equal to 0, which makes it an equation? I'm trying to find what x values would result in 0. So if I graph it, I can take a look here. It appears to be a 0 here and here and here. So to find the zeros on a graphing calculator, I push second, trace 2. I give a left bound. So I want to go to the left of this particular 0, push enter, and then I need a right bound. I'm going to go to the right of that particular 0 and push enter. The next thing it says is guess, so I'm just going to push enter one more time, and I have a 0 at -1. So let me go over here to my choices, see if that eliminates anything. I have a 0 at -1, which is a choice on 3 of them. D's out. All right. Well, I can already tell that I have 3 zeros. If you look here, 1, 2, 3. So if I find the next one, there's only one choice that has 3. It's this one. But let me find the next 0 or see if 1 is a 0. It's going to be hard to tell, but -1/6, you may not know this. If I do this second trace 2, and if I come over here and I put a left bound and a right bound, I get -0.166667. That's -1/6. So my choice is going to have to be A, because -1 and +1, and I can check the table to make sure both of them are zeros. -1 is a 0, +1 is a 0, and there's another 0 at -1/6. So that's my answer. All right, next. On this one, I can do it on the calculator if I want to, or I can do it by hand, set both of these factors equal to 0 and solve. So here I would add 7 and divide by 2, so 7/2 should be a 0. So this is going to be my answer. And here I can add 1 and divide by 2, and I get my other one has to be 1/2. So 7/2 and 1/2. You can also type in your calculator just like I did the last one and do the zeros using your second trace 2. This one, you can factor it if you'd like. If I factor it, or you can put it in your calculator. If I factor it, I get y squared minus 2y minus 15. And then I would get y minus 5, y plus 3. That's how this factors, because I need two numbers that multiply give me a negative 15 and add up to a negative 2. So I get negative 5 and positive 3. So if I solve it, I get y equals 0. Y minus 5 equals 0, which will give me y equals 5. And y plus 3 equals 0, which gives me y equals negative 3. So my answer is going to be 0, 5, and negative 3, which is B. You can also type this in your y equals your calculator. Y cubed minus 2y squared minus 15y. My only problem with doing that here, I'm going to use x. X cubed minus, forgot what it was, 2x squared minus 15x. 2x squared minus 15x. And when I do this, I'm not going to see them all because one of them was at, I think, I'm missing one. Oh, no, I got them all. Right here, and right here. And you can do the second trace too, or you can go to your table. And on the table, I can see the zeros are at negative 3, 0, and positive 5. All right. Number 19. Use the graph to find any relative maximum minimums. Well, you got to put this in your calculator. Absolute value of x plus 2 minus 1. So I'll go to my y equals. The absolute value is math, and then you go over to number. X minus 2. And then on the outside it was minus x plus 2. I messed that up. X plus 2. That'd make a different answer. X plus 2 on the inside, and then minus 1 on the outside. And graph that. All right, looks like to me there's a relative minimum because this comes to a point. So I'm going to find that value. Second trace, well, second trace. Something's not working here. All right, I'm going to move on because I want to get this done during seventh period, but my calculator is frozen. You would push second trace and then do minimum, but I can look on here and tell this minimum value is -1 when x is -2. That -2, -1 is my minimum point. So looking over here, there's a relative minimum of -1 at x equals -2. That's the only one that has a minimum that's a negative number. So that's going to have to be my answer. Number 20. All right, we're going to graph this one. All right, I'm going to pause and see if... All right, I've gone to the calculator and typed in this equation that was over here, -x squared plus 6x minus 7. They want me to tell if there's any minimums or maximums, or if there's not any relative extrema. So I'm going to graph it. And this appears to have a maximum right here. So it looks like it's about at 2, but just to make sure, I'm going to do second trace. I want a maximum, which is 4. It needs a left bound, so I'm going to go up here kind of close to it, give it a left bound, enter, and then it asks for a right bound, so I'm going to go over here and make a right bound, enter, and it says guess. I push enter. There's a maximum of 2 when x is 3. A maximum of 2 when x is 3. C is my answer. Be careful, not a maximum of 3 at x is 2. Don't get those backwards. All right, here we have x squared minus 3, so I would just type that in, y equals x squared minus 3, and graph that. I think I can eyeball this one. There appears to be a minimum of -3 when x is 0. -3 when a minimum of -3 when x is 0. All right, determine algebraically whether the function is, 22. Determine algebraically whether the function is even, odd, or neither. 4x to the 5th plus 7x cubed. We looked at doing this a few different ways. Probably the easiest way is to graph it. Take a look at the points and see if those points are opposite each other, or if the different x's give you the same y. Okay, if I had to guess on this, visually it appears to be odd, kind of rotated around. The y-axis is not cutting it in half, so it is definitely not even, because I would have to have a mirror image on this side as to what I have on this side. So if anything, it's odd. So let's go to our table and check algebraically. For -5, I get negative 13.375, and for +5, I get positive 13.375. -4, negative 45.44, +4, positive 45.44. So again, it does appear everything is exactly opposite, which means that this function would be odd. All right, we'll keep on going. Almost done. 23, even or odd or neither. 4x squared minus 5. 4x squared minus 5. Clear this out. 4x squared minus 5. Graph it. This appears to be even. It looks like the y-axis is cutting it exactly in half. Let me check the table to verify this. And if you'll look, you get -595 and +595. -459 and +459. So that does confirm for me that whether I put in a negative value for x or a positive value for x, I get the same output. So this function is even. And 24. A graph of functions shown below, find f of -0.9. This is your x value. I want to know the y value. So if x is -0.9, y is 2.641. That would be my answer, 2.641. Number 25. A graph of function g is shown below, find g of -1. Again, that's my x value. So here's the point I'm using. When my x is -1, my y is 0. All right, 5 more. 26. Use a graphing calculator to find the zeros. 2x squared plus 2x minus 5. 2x squared plus 2x minus 5. 2x squared plus 2x minus 5. And graph it. Since this is x squared, I'm anticipating 2 zeros, and that's what I have. One over here and one over here. This won't let me draw on this. I'm going to push second, trace 2. So I'm going to find the one over here on the left first. I'm going to move to the left of that 0 and hit enter. That gives me a left bound, and then I need a right bound. And so what I have here are 2 vertical lines and my zeros in between them. It says guess. I'm going to push enter one more time, and one of my zeros is at -2.158. -2.158. So this has to be my answer. It's the only one that has that one for a choice. I'll come back over here and just to make sure, do the one on the other side, make sure I get the other answer. Second trace 2. Move over here close to this one. I need a left bound and a right bound. And there you go. 1.158 would be the other one, which is exactly what it says. 27. X squared plus 10x minus 3. I am running out. I'm already at 18 minutes. You do that one the same exact way. Type it in, do your left and right bounds. Same thing here. This one wants exact answers. It should hit exactly at a point. And same thing here. X squared plus 7x plus 7. I got a minute and a half. I'll do this one. X squared plus 7x plus 7. I want to keep it under 20 minutes. X squared plus 7x plus 7. Is that what I said? Plus 6. All right, graph that. And I've got a 0 over here. I can count them. -1, -2, -3, -4, -5, -6. -1 and -6 would be my zeros. -1 and -6, my answer would be D. All right. 30. Determine the domain and range of this function. Now this one, I'll be honest, for some reason, if this was colored in, it'd be correct, but I don't know why it's not colored in. So you'll have to tell me if something's not right on your test. Sometimes when it produces extra ones, it's not. Sometimes it can create a wrong question. So the domain is from -infinity to +infinity, and the range is from -3 with an open circle to 3. See, this is not right either way. There's not a good choice. I don't know whether to choose A or B, because with that open circle here, there's really nothing you can pick. So hopefully I'll go back and check all the tests from tomorrow and make sure there's not one here. The domain should have been from negative infinity to negative 2, and then from negative 2 to infinity. That should have been the domain. And then the range should have been from negative 3 with a parentheses to positive 3 with a bracket, making this the answer. I'll go back and check and make sure that nothing printed out wrong, because this one, none of the domains are right on any of these, so that kind of messes up the answer in the end. All right, see you tomorrow. Good luck studying.